Implement Trie. Prefix Trie, a Trie or prefix Trie is a tree data structure used to efficiently store and retrieve keys in a dataset of strings. There are various applications of this data structure, such as autocomplete and spell checker. So they have the insert function, search function, and then the start with function to check uh, if there any is there any string that starts with this prefix, something like that. So how we are gonna save this requirement of which kind of data structure we will use that. So as it's saying like tree, right? So the way I'm gonna do it, I will just construct a tree. We will have a root, and then in that root they will have many chains. For example, we will start from A to Z, right? So 26 word, they will have the root can have the 26 children's maximum. And then in each single chain nodes, for example, if we start A can have also 26 children because there's our characters from A to Z is 26, right? So every children's or every node in that tree can have 26 children maximum. So if we want to solve this problems, we can do according to my test codes. I can do two ways. The first way is I will just create a data structure in that nodes or something in that node. I will just keep if it is the end or not, because for example, if we have apple apple, sorry, if we have apple apple, we will have the tree turn the root. We will have a node, right? And then it has the child with the p node, and then p, and then l and e. So this e node will be marked as like is the end or not something, right? So they are not the end, right? So I will mark this one is end or not the first way and the first thing. And then for example, if I added another strings, is called app. So at the time, okay, a we already have that, so we'll just save the memories, right? So we will just reuse this. Okay, we have a p, we have p, and then we have p, and then we'll mark this p again as this one is the also the end. So in this route we have two strings, apple and then app. Okay, so let's do this. So we will have is boolean value is the end or not, and then it's children's. Okay, so let's do this. Okay, I will create a data class. Pupil is public. I will call that one as a node, and then in that node, oh, so I was just talking in two ways, right? The first way is um, the first way I'm gonna do is I will save the children, right? So for the first thing is the end or not, and then second thing is we can use like this node array for the child, or because if we have to instantiate this child, we have to create empty array, right? So in this we will have the node is called root, and then it will have 26 children, right? So in that 26 array roamed, they will be empty, and then if it is coming a, we will just change that character code by using like minus small a, right? So we will get the row number, and then we will see to the row number. So if I use the dictionary or hash table in C#, so we like a hash table, like right, hash maps or something. So if we are using that, we can save that. I think we don't have to create like 26 room for the array, right? So we'll just save only if we have the child node. Okay, so this case I will just create the dictionary. We can use any way we want, but I prefer this one, so I'm gonna do this one. We will save the character values. For example, if I have this one, okay, if I have this one, we will save this p and then is notes with P again, right? So and then note, right? In that note, it's gonna be the is note, P note, right? Okay, so and then in that constructor we will instantiate is int equal force, and then child is gonna be new ctr1 er1 dictionary char comma note. I will just instantiate, right? Okay, so we got the class to use. Let's start. When we start, we need to instantiate as a very node, very root, right? As a node, I will call that one as a root. For the first time, we just put that nar, and then when we call that tire, we will just call that node. Okay, we have very root node, so it is not the end, and then it don't have chain yet. Okay, when we insert, we will insert to that node, right? So node equal to know the current node. Okay, node. Okay, I will go every elements, every parents to that. For example, if it is that A, I will just check, hey root, do you have any chain with is called A? Okay, let me check in my dictionary values, right? So by doing this way, we have to check every nodes, right? Character C in what's stop, because this one, right? So we need to add every characters, right? This word is just string, so we will change from string to character array, and then we will get the first element C, and then we will check every node, every parents, right? Okay, so if hey node, hey root, do you have any chains like that? So okay, let me check to my array or dictionary. Like now I just use the dictionary, so I don't have to check the array's index number. If we use the array, we have to check its array number by converting the character. For example, if it is A is like a 65 or something, I'm not sure, as Kiko is 65, so to know the room number, because A is gonna be in the room number 0, right? So A minus A, so we'll get 65 minus 65, so it's gonna be 0. So we need to convert from the character to integer to get the array index. So now it was easy, just easy for this case, right? But we can do anytime any data structure we want. So hey root, we have this children, no we don't have child. Okay, we will just add that child. Okay, chrd child dot add, we will add, right? Okay, key is just C. For example, if it is A and then new node, we will have the node. Okay, if, and then if it is not, we will keep going, right? If it is already A, okay, we will go to this node. So we have to move the node to the node.chain, right? Okay, so by doing this way, we will go and we will add A, we'll add P, we'll add L, we'll add E. So the last node is gonna be end. It's gonna be the end, right? So we will just change node dot is, and it's gonna be true. Okay, so we finished the insert. Okay, let's search. Okay, let's search. How are we gonna start search? We will start searching from the root, right? So we'll just create a new variable called node. We'll start from root. Okay, so we will just loop like this. We'll loop. For example, if we have APPLD in our Trie data structure, and then if we look for APP, okay, we will loop every characters that you want to search for, and then we will loop. Okay, for like the same, and words dot to char array. Okay, let's look for one by one. Okay, if hey node, do you have any chains that start with that uh, that has this value, this character value. For example, if it is A, we need to check this contain A or not, right? Contain key C. Okay. Hey, no, there's no chance. Oh, oh, there is nothing. Okay. If we don't have, right? Let's force. If it is, we will keep looking for, right? Node equal node dot child C, right? Okay, and then we'll keep looking for, and then, because for example, if it is studying what, it is what, right? App. P is not the end. We need to search. If only P is the end, we need to return true. If it is not, this one is just a middle value, right? This is called like this. If we look for app start with the function start with, we need to return true, right? But if it is not such, when we search apps, return false. It starts with app, yes, true, because we only have apple, so we need to return no dot is end. If it is not end, we cannot call this is a word. This is just a start string from another word, right? That's why. Okay, so the same for the start with, right? So I will just copy this one and then put this one, and then we have where loop every prefix characters, and then we'll keep looking. If it is not contained, we'll return false. If it is not, if there is content, we will keep looking for, and then finally we'll return true. Okay, let's run this one to see what will happen. I hope it works. Yes, so I'm gonna submit this one. Sometimes if it is running too time, if we got a runtime error, we can change the data structure, like a dictionary. I think if we use the array with a node array, I think it's gonna be change this result, but the same. Whatever we use, the logic is the same. Okay, so that's it. Thank you.